Webinar on managing VSAT networks for optimum performance. My name is Robert Bell, and I'm Executive Director of the World Teleport Association. I'll be your moderator for the next hour. WTA, if you're not familiar with us, is a nonprofit trade association that advocates for the commercial interests of teleport operators and also promotes excellence in operations, technology, and business practices. Our goal is to help members deliver the highest possible quality service and meet their goals for revenue and profitability growth at the same time. In addition to programs like this one, we conduct and publish research on a wide range of topics, including our topic today, managing VSAT networks for optimum performance. Our reports are available free to WTA members and for sale to non-members, and you can see our complete library at www.worldteleport.org by selecting Reports from the menu. Today, our agenda is in 4 parts. Following this introduction, I'll share some key insights from our report, and then we'll hold a discussion with a distinguished panel before turning to your questions. And that panel is well worth hearing from. It includes Karl, Reddy, Director of Global Services, Service Assurance Systems at SES, Guido Neumann, who's Chief Development Officer at AXESS Networks, and Greg Quiggle, Vice President of Product Management for Kratos. This report and the webinar itself are both sponsored by Kratos. And that company provides advanced solutions across the space and ground segment with products and services that manage and optimize satellites, signals, and networks. Pretty broad remit, and we're very grateful to them for their support of activities like this. VSAT networks. Once upon a time, they were a standalone solution to a fundamental problem: how to connect dozens, hundreds, or thousands of locations on a unified platform that delivers dependable quality of service regardless of what's going on in your own local network. Today, they're operating in a different and much more complex world. RF interference continues to rise, generated, ironically, in no small part, by poorly installed and operated VSAT terminals. What was once a closed RF network is now an RF plus IP network that integrates with the enterprise network and may be managed by IT staff with little or no satellite experience. And finally, the sheer number of terminals in operation these days and the huge growth in traffic across them makes networks harder than ever to manage. So we asked a set of respondents in our report to talk to us about what their top challenges were, how they were attempting to meet them, and specifically how to deal with, well, how to deal with a flood of data such as the world has never seen. So the challenges that they came back and told us about were very customer focused. First of all, very high expectations. Customers are more demanding than ever been for the quality of service, which means that teleport operators have to invest in more redundancy than ever before. At the same, and speaking of more, customers also just want more for less money, more bandwidth, more sites, which creates inevitable pressure on margins. Rising complexity, the rising number of VSAT applications is operating a network that has to keep delivering more for less, and that's complicated by the fact that we are still in our marketplace have multiple manufacturers with different strengths and not a great number of open standards to which everybody applies, and that can make it very hard to get the best from your equipment. And then finally, more upstream traffic. Network traffic is increasingly symmetrical, whereas it has always been highly asymmetric. And that's, of course, because of video. Users are making videos and sending them, and that's just completely changing our expectations of how the network actually operates. So in terms of what operators are doing to protect their futures, preserve their margins, and deliver a better quality of service, a number of things came up in our interviews. First of all, just starting out right makes all the difference. So universally, the operators said that it pays to give careful attention to setting up the network, precisely mapping the network, the terminals, merging in third-party sources of data that help you manage the network proactively against the threats to its quality. Protecting against interference is the same requirement. You do a better job of it if you start with the right technology, if you start with careful planning. Several of the respondents did note, however, that what you do, you still have to have that tool that's going to rescue you in the end, and quite a few of them recommended a new system actually from Kratos called StatGuard, which is able to pinpoint the precise location of a terminal causing interference and do it in just a couple of minutes, which is quite a leap forward. Customers increasingly want somebody to take end-to-end responsibility for quality of service, not surprisingly, and teleport operators and satellite operators as well are stepping into that requirement, even though a lot of the network they don't control. And so they're working hard to provide levels of redundancy that we haven't seen before, and to do it not just in hardware, but actually for the IP service as well, which is really quite remarkable. One operator we talked to not only makes the RF side completely redundant, down to redundant satellites and teleports, but includes redundancy at the IP traffic level. That can be what another operator uses, which is something they call a permanent ping system to monitor both the RF carrier with a second modem, but also the IP side of the business. So it's not your grandfather's VSAT network anymore. And finally, dealing with the data flood. We now have monitor and control systems that are generating just massive amounts of data on the operation of the network, which is terrific, except it very easily overwhelms the ability of human operators to manage it, which means that we're turning increasingly to machine learning and data analytics to deal with that issue. And we'll talk more about that in just a moment. Finally, what's ahead? What's next? What are the operators thinking about is going to shape their future? 5G is certainly on the map. As a means to increase business, but also, of course, potentially as a concern because of the overlap of 5G with some of the C-band and Ka-band bands, I should say. And finally, LEOs. No one is quite sure how it's going to work out because they're not really in operation yet, but they're expected to become a significant disruptive force if they make it a successful service. How it combines with the existing satellite network is anybody's guess. The number one value, however, that the operators all see going forward is if it works, they'll be seeing lower prices for more capacity, and that's a very high value. So enough from me. We now turn to our panel of experts to hear their views on the challenge and opportunity of managing VSAT networks for optimum performance. So welcome to the webinar, gentlemen. Karl, Guido, and Greg, we're pleased to have you with us today. Let me get started with our first question, and what is the big one, which is what are the key challenges today in managing VSAT networks and optimizing them for both performance and quality of service? And I think we'll start with you, Karl, because you're over on the left side of the screen here.
Yes, thank you. Thank you for the question. I think that one of our biggest challenges with well, we've got two main challenges with VSAT networks. One of them, I guess, is the increasing use of growth of mobility services, both maritime and aero, and being able to the classical lineup mechanisms we used in the past for fixed networks no longer apply to mobility, because as soon as the vessel or aircraft takes off, then the antenna is moving in all directions. We've got skew problems. It's very difficult actually to track the performance of antennas flying through multiple beams when they're switching beams every 15 or 20 minutes or so. So tracking that, tracking interference, in fact, in an environment like that is very challenging indeed. It's something that we're currently working on, but it's we're using data that we get from these terminals, like GPS coordinates, real-time KPIs, ESNOs, CRNs, to try and build a picture of where they are, and if there is a potential interference problem in a specific beam at a specific time, then we use these metrics to try and work out who is it, where is the aircraft heading, is he banking, is he turning, this kind of stuff.
And of course,
sorry,
Karl, I was going to say, and of course, the interesting part about that is it is from mobility that we expect most of our growth in the industry to come. So yes, it's a problem well worth solving.
It is. It's particularly challenging because, of course, when you're using these flat panel antennas, the performance of those antennas varies depending on the angle that the antenna is transmitting at, the skew angle, the location inside the beam, and also the overall environment, sort of adjacent satellite environment. If you're close to beams from an adjacent satellite or operator, then this is another level of complexity, us causing interference potentially into another operator and vice versa. So that there's many moving parts in this area. Maritime is a little bit, it's easier to control because, the vessels are moving slower. We have the same types of data sets from maritime vessels as we do for aero, like location, the registration of the antenna. We also, For both sectors, we also have AIS and ADS-B data globally now available from commercial providers. So we, with LEO constellations filling in the gaps over the oceans, we can cross-check where a vessel or an aircraft is in flight if he happens to lose connectivity and that kind of thing. On the other side, on the large scale broadband or fixed data networks, we see a big challenge there is that there's often huge rollouts of VSAT terminals, and traditionally an SES with enterprise terminals that we would push those through a NOC or a PMOC to conduct lineup activities, but these days it's just not possible to handle that volume of kind of SES lineups through a NOC. So what we're doing is working with vendors to use automated systems that are normally provided by the platform vendors, and also build up trust relationships with key customers to make sure that they have certified installers, and that those installers are properly trained, and also there are regular audits of the quality of their work on the customer side, but also on our side to make sure that they maintain a good quality of installation. That's one way to keep the interference down. Of course, with SatGuard, we have the capability and the possibility to audit these networks regularly, and pushing back reports back to the customers to get them to clean up substandard installs. So lots of moving parts, lots of challenges. But I think the key. Sorry, go ahead.
No, I was just agreeing with you. I think it's a massive challenge. Let's move on now, because you've already thrown out 3 or 4 major things that, quite frankly, are daunting to a huge degree. Guido, why don't you tell us how it looks from the point of view of a ground segment operator in multiple regions now?
Yes, first, thank you to WTA and Kratos to be part of this webinar. I'm very excited. And as a service provider working globally, I think the main challenge for us is really that the complexity is growing, and the complexity is growing in all areas. You work with different satellite operators, and as mentioned by Karl, we work a lot with SAS, but even within SAS, only from one operator, the complexity is increasing. Different kind of satellites, different technologies, MEO, GEO, O3b mPOWER is already ahead. And at the same time, we see that on the ground segment equipment, that here the hardware and the hub, you have more terminals, more technology available, which becomes more and more complex. And then even more important is when you look on the customer sides, our customers in all the different verticals, we touched already maritime and mobile avionics, but also in the oil and gas sector, in the mining sector, in the NGO sector, the government sector, they have more and more applications to run over their communication lines. Yeah? And they not only now want to have only one empty pipe, they have their special applications where you have to look into. Some applications are latency relevant, others are not. Some applications are happy with a low-end DSL connectivity, and others need a dedicated line. Then they want to be very flexible in their bandwidth. Today they want to have maybe 10 megabit in this country, but then they want to move to 10 megabit in the other country. And we as a service provider, let's say roughly handle about 25 to 30 different value elements, from the poor space segment to the teleport facilities all over the world, up to the ground segment of the customer. And here what we also seeing coming up is this more and more SD-WAN approach. So we have more and more hybrid solutions. It's not the single VSAT connection at their end. It's sometimes combined with Wi-Fi or with LTE or 3G devices, so that they have the different things there. So summarizing, the challenge today is the complexity and to keep up to date with all your team on this complex stuff.
As always, making it simple for the customer means making it unbelievably complex for ourselves. So thank you, Guido. Greg, so now your gear has got to somehow help teleport operators and satellite operators make this all work. What are the key challenges you're seeing?
So thank you, Robert. Just to follow on to what Karl and Guido said, I think probably the most significant thing I would want to touch on beyond is, Karl referenced mobility networks, and there's certainly a lot of complexity in managing them as they are today, because the terminals themselves are moving. Just with a small look forward, I think it should heighten the urgency and importance for this topic. You're looking forward, and I would say that by really just mentioning the fact that the number of satellites actually in the coming years are going to grow exponentially, all sharing the same bands in many cases, and certainly with MEOs today and soon to be with LEOs, they're also moving. So not only is it difficult today in a mobility network because the satellite, not always, but is typically geostationary. In SES's case, they have a MEO satellite constellation as well. But as the number of satellites increase, and as the movement increases of those satellites, the likelihood of interference will go up. More importantly, most of the interference events will be very transient. So your ability to manually troubleshoot these things over a period of days to weeks is really obsolete, because the actual interference condition might only exist for a few minutes and maybe repeat on a regular basis. So the need for tools and machine learning and AI techniques to be able to properly understand ideally what the root cause is for the interference and actively troubleshoot it while it's occurring is going to be increasingly important.
By the time you're finished, I think it's you three gentlemen have outlined the fact that really this can't be done. So we might as well just stop doing it. No, it's really quite a remarkable set of challenges, and maybe you could address now for us the issue of scaling it, because as you say, as all of you kind of hinted, the sheer volume of all of this is going to rise very, very, very fast. And so how do in your own operations, and also as you deal with your customers, how do you deal with it? How do you address that in your own operation? How do you make sure that you can deliver the quality of service while it just scales upwards and upwards? And Greg, since you were talking, why don't we just turn it back over to you?
I think a big part of scale, the answer to scale really lives with standards. And there's been a lot of recent movements in the industry to really enable the industry to adopt not only specific standards for satellite communications, but also more broadly for the terrestrial marketplace that we oftentimes interconnect with. Certainly 5G has been a big opportunity for that. Obviously, the new standard rolled out in the process of rolling out for terrestrial wireless networks. The 3GPP standards that govern 5G have opened the door, frankly, for the use of that standard to manage satellite networks as well. So driving to more common standards within the industry will actually help a lot to really enable the networks to scale more effectively, not only from an over-the-air standpoint between the hubs and the remotes, but more importantly from a standard networking standpoint as well.
Interesting. Guido, do you think that's one of the answers is standards?
Standard is an answer, but as you know, we have a lot of different suppliers, and some of them also, you see there's a consolidation in the market, just looking to iDirect and NewTek, but also new suppliers coming up with new technologies, new startups, and only looking on the terminal side with all these different antenna manufacturers and different technologies on flat panel antennas. It's sometimes difficult to create a standard. What we see, again, as a service provider, it's very important to work together very closely with your suppliers. On one hand, it's a big value for the service provider to stay independent, so that we can really offer the customers maybe the right satellite. Sometimes it's SAS, but maybe sometimes it's another satellite operator. Sometimes we need this technology on the ground, sometimes another technology. And this variation will become even more complicated with we will talk later about it, with the LEO constellations and the new MEO constellations and the new terminals. But again, I think it's more important that you have good experts and professional staff in your own team, and you have good, very excellent, close relations to your suppliers, so that you even work together on a specific project, and then you also need partners on the ground, which you can rely on.
Thank you. Karl, so the challenge of scale, serving things that move and dealing with the same issues except exponentially much larger, how is SES addressing that? Well, Karl, we're not hearing you. Could you try again? Well, we'll hope that oh, he's back. Hello, sir.
Yeah, sorry, I was trying to unmute, but I was muted by the organizer. Can you hear me?
We can hear you now. Thank you.
Oh, okay. Sorry, I don't know what's going on there. Anyway, yes. Well, just to address the standards issue, we are actually in SES. We are pushing. I mean, the standards of VSAT platforms. You know, there is some sort of more cooperation now than there was in the past for at least for new projects that we're working on. But we are pushing vendors actually right across the board, not just in the IP platform side, but also ground infrastructure side, to provide us with standardized API connectors into their systems. And this is key for us, especially moving towards the mPOWER and SDRM, or the dynamic resource management in the future. With the next generation of MEO spacecraft, we need KPIs and metrics from ground and platform systems at a high rate in order for us to be able to effectively machine process and, you know, conduct situational awareness analytics for the operations teams. And that is something we are driving and pushing vendors to provide us. So traditional files or SNMP type stuff is really no longer adequate for our needs. So basically, our ability actually to effectively manage these networks and be efficient is really based on data. So it's data backbones, data lakes, the analytics and artificial intelligence part, automation also, from service provisioning to service operations, you know, giving customers the ability to manage their own networks across multiple platforms, platform technologies, the automatic detection of anomalies and the reporting of that to customers, QoS, that kind of stuff. So this is really is a major drive inside SES to really provide a rich experience for customers and give him the capability to effectively manage large-scale networks across, you know, GEO, MEO, and all sorts of service types. So this is really a key differentiator for SES. The capability exists today, but we really need to scale up for the future. That's for sure. And of course, work with our tools and analytics partners to get there.
So, Robert, one thing I would add to Karl's statement, just further on the standards topic, you know, news that's broken perhaps since the release of your report. Just about a month ago, there was a new working group that was kicked off by sponsorship of AXESS, and it's a 3GPP NTN working group. And really, the charter for the group is to drive common standards for satellite networks within a 3GPP architecture in time for 3GPP release 17. 3GPP release 15 is the first that supported basic 5G networks. The reason why I bring it up is you know, I think it's been a fairly hot topic over a number of years, and the industry's usually struggled with standards and, more importantly, interoperability. You know, it's been real nice to see the momentum really over the last 6 months to a year on this topic. Within that working group, not only do you have SCS participating, but also many of their peers within the industry, including folks like Inmarsat, Telesat, and Intelsat. So, I think the industry is seeing the need to drive to common standards as a way to scale, because as we're talking about here in the context of interference, the complexity is significant. So we need things like standards in our place to really make the problem more manageable as the networks get larger and larger.
And Karl, I think that's, excuse me, Greg, I think that's a great point. The other thing that standards typically have always done is, frankly, to grow the market for us. So yes, it's a great thing that we're focusing on that now. So thanks to the mobile industry for forcing this all to happen by introducing 5G, which is one of those unexpected outcomes, right? One of the sort of remarkable challenges to me as we work on this report was this idea that now the teleport, the satellite operator, has to begin taking responsibility for the entire network, including lots of parts that operator does not control. Guido, I want to start with you on this one. How do you assure that quality of service across the entire RF to terrestrial systems of a network like this?
Yeah, we have also on our side similar tools in place as mentioned by Karl earlier. For example, a very good monitoring tool and system is required, that you have not only people who are reliable for controlling network, you need devices, you need automatism. So we also control and monitor the IP and the RF. We call that dual layer monitoring. So we did do it similar, as mentioned earlier. We do a permanent pinging on these networks, on the IP stuff, on the IP path, and at the same time we are also monitoring the frequencies with the RF modems. Yeah? Looking into global operations, and we now work in the Americas and in LATAM and the EMEA region. Also here, again, it's not only the tool, but also when you want to react on an emergency or a trouble, then also here the whole management process has to be optimized. So you have to be sure if there is a failure on a hardware somewhere in a rural area in Africa, that you also have in advance prepared by yourself, either with spare parts, or that you have also a good partner in the country who is able to went to the remote site and to support the things. Or even you can also work with your customers and train them here. So the whole chain of the service provision from one end to the other, unfortunately, cannot be managed only by computers or maybe artificial intelligence. Sometimes it's also manpower required. And here, for us, it's very important to have clear, standardized and well-defined processes within your company, but also with your suppliers and your local partners on the ground.
Guido, that's a great answer. Yes, it's good to know that we're always going to need the incredible ingenuity and skills of people to make it all work. Karl, how does that same question look from your point of view? Because you're a satellite operator, but of course you're having to take responsibility for a great deal more now.
Yes, well, I mean, this is something that we're working very closely on for the MPower project, for example. So we are already testing a software-defined network solutions for in fact all of our infrastructure. We are now basically the underlying link, whether that's a terrestrial link or a MEO link or GEO. For us, it's underlying infrastructure, and our future lies in software-defined networking mechanisms where customer traffic will be transported through the best available link, depending on where he is, what the demand is for bandwidth, and also the quality of the any particular link at any particular time, and that includes, is the available throughput, on GEO or MEO. If there's a demand for higher throughput, then you would switch to MEO. For the customer would be completely transparent and managed by a global software-defined network. And this is something that our customers are asking for, and it's absolutely critical for for the next generation of satellites and services, that the customer is not really, shouldn't be worrying about underlying infrastructure. He should have a virtual pipe transiting either satellite or terrestrial components or a combination of those. So this is something we see a huge growth in the future. And yes, you're right, we are a service provider company, not a satellite operator anymore.
That's correct. Yes, everybody is. Just going back to Guido's scenario, it's we have a customer in Africa, the service is down. We can do all the software-defined, slinging around of service that we want to, but at the end, there's an issue of the path. If it's there, if it's out, it's out. So what I'm really circling around to is the question of redundancy. Is another aspect of this for you at SES that you're just going to have to come up with a lot more available paths for your customers in order to really ensure the quality of service?
Yes, in fact, this is already the case for example, in the cruise ship market, where your prime link may be a MEO terminal on board, or a couple of MEO terminals on board a ship, and there's already architectures in place where there is a geo backup, and that backup can be a backup for critical traffic or crew or communications. It can also supplement what's already available in MEOs, but the switch from one to the other is seamless, and that solution can also include terrestrial options if you are close to the coast or in port and that kind of stuff. So for the customer doesn't really want to have to worry about which service is being used or how long it takes to switch. He wants it as a transparent, always-on solution, and it's up to the service provider to provide that to him and also provide a good level of visibility.
Yeah, of course, and that's really ultimately what is driving it. The customer has a perfectly reasonable expectation that it's not their problem.
Yeah.
Greg, what can we do from the technology side on this?
So Robert, I would actually tell you, I'm going to just further on a technology that Guido mentioned that's growing rapidly in the terrestrial marketplace today and just starting to get exposure in satellite, and that's SD-WAN, software-defined wide area networks. Very similar to what Karl just described as well. When you think about diversity and redundancy, certainly in satellite, we oftentimes immediately jump to the satellite link itself, which certainly is a critical piece. But actually making that transition from one path to another transparently for the user also requires you to be able to manage the IP network equally as effectively. And that's really what SD-WAN is fabulous with. The technology was really intended for you to be able to use multiple access network techniques, whether that be satellite, wireless, a metro Ethernet, or standard broadband, but then have a common IP path over those variety of access networks. So when you implement SD-WAN in a system like a satellite network, it actually is a great way for you to manage the IP network complexity of a redundant satellite link, or as Guido actually mentioned earlier, and Karl did recently in a case like cruise, where you also have a scenario where you could use a redundant link that's not satellite. It could be terrestrial wireless, for example. For that technology to work, unfortunately, it gets right back to the standards topic again, right? SD-WAN works really well if your Ethernet network is Metro Ethernet Forum compliant. And that's also been somewhat of a struggle for our industry over the years. SES was actually one of the first satellite companies to actually join Metro Ethernet Forum. Kratos joined earlier this year, and really what the intention is there is to make sure that the Ethernet frames that are sent over the network are compliant with the rest of the terrestrial network space. And when you do that, you can start to leverage technologies like SD-WAN to solve some of these problems that are somewhat complex, specific for a satellite network.
Thank you. That's really, it is an important technology. Just a reminder for our listeners, you do have the ability to share some questions with us. I've got a couple of them already, but feel free as things cross your mind to add them to the discussion. Let's talk specifically about the issue of interference. It's always struck me as one of the amazing ironies of life that it is VSAT that causes a great deal of it for reasons of, because of poor installation practices. And I think it was you, Karl, referred to that as a critical issue. So what are some of the practices and technologies that we can just use to minimize this problem in an increasingly complex network? And Karl, why don't we start with you, because you'd already opened up this topic.
Well, actually, one of our key tools, I mean, for interference, especially VSAT networks, is SATGuard, in fact. And the SATGuard concept was born in SES many years ago, and we worked with a partner in Norway, which is now part of Kratos. But the SATGuard system itself is today the most important tool we have to fight VSAT interference. We have data from the platforms themselves, if we own and operate those platforms, which is kind of supplementary, but the ability to passively identify and identify terminals on VSAT networks from platforms that we may not own or operate is critical for us, and it produces an enormous amount of data. Right now, I mean, the analytics tools that we have available in SATGuard from Kratos have certainly improved over time. But as time goes, we're dealing with tens of thousands of terminals. Being able to effectively process that really in the background and remove the kind of human element out of that process is something we're working towards, because it is quite labor intensive. Processing those results and then presenting them to customers, especially if there's if we have a kind of a regular exchange with them as they clean up their own networks. They rely on us providing them with the updated measurement metrics. And really, the next step should be that the system would be completely automated, and that the customer would log into a portal and be able to see the state of his population at any moment in time, and also see the improvement as he realigns or readjusts terminals in the field. This is something that I would like to see. So for us, I would like to see it as a hands-off system, and that we were provided as a service to operators. And of course, we could then track progress as he cleans up his network. Or if in fact there is a spike in interference due to a local storm or a typhoon or whatever, then that would be picked up quickly, and then the customer would be alerted, and we would be able to track then progress in solving those issues. So right now, there's still quite a lot of man hours involved in managing that data and managing the relationship with the customer. I think our goal is to automate this completely in the future, and produce analytics for both customer and also us, the service provider.
Yeah, that's quite a vision, Karl. That's wow. That would be then you would now have arrived, and you could die happy.
Yeah, I mean, it's a vision actually for not just for interference. It's right across the board. It's a right across the service landscape. In fact, everything we do in operations, we are looking to increase levels of automation right across the board. And it's easy to say, not so easy to do, but it's critical for the satellite industry moving forward, considering the increased competition in the future with potentially large numbers of LEO satellites and then 5G as it rolls out in the future. So we need to become much more efficient and leaner in operational activities.
Well, and that will also, I mean, not to get too far off the track here, but that will also contribute to what I think that is the number one job of this entire industry, which is to become a more deeply integrated partner of global telecom. And to do that, we're going to have to basically operate like the rest of the industry does. So yes. I couldn't agree with you more. Greg, so what's in the technology toolkit in addition? First of all, you must love hearing this about SATGuard, but what's in the technology toolkit to help operators deliver that quality of service in spite of interference?
Yeah, and I delighted to hear the use, and was well aware of it. Certainly within SES, they've been one of the innovators on this front for a number of years, and actually worked with the company that we acquired before we acquired them. Since we acquired that business, what we've really been focused on at Kratos is integrating that into an even broader RF tool set. So if there's really three primary tools that we use to manage the spectrum, and they're pretty widely deployed in the industry today. So in no particular level of importance, the first I would say is Monix. What Monix does is really generically measures the carrier or monitors the carrier plans for both the forward and the return links within a given network. What SatGuard does is, as Karl mentioned, is then within a given carrier, you can actually analyze the traffic. I'd like to call it deep carrier inspection, not unlike deep packet inspection. So within a given carrier that you see in Monix, SatGuard allows you to say, you know, that's a Galat network, or that's an iDirect network, or that's a NewTek network, and even in some ways actually identify the physical terminals themselves that exist within those networks. And then the third suite of tools is SatID. And what SatID allows you to do is if you identify a terminal within a carrier that shouldn't be there, that would be an interfering terminal, SatID through the use of reference terminals allows you to essentially triangulate the location of the terminal so that you can very quickly identify the source of the interference. So those three tools commonly are used together by many of our customers, including SES. Looking forward, one of our primary initiatives within Kratos is to really tie the data sets of those three tools together. And in doing that, what that allows you to do then is, as the network scales, you can start to leverage techniques like AI and machine learning to automatically detect these problems and make it less about, you know, of a manual effort looking at a user interface and more about a machine doing a lot of that work for you, and then maybe pushing key you know, problems upwards to the staff that you have on more of an event basis. So it's very, very similar to what Karl's asking for.
Yeah, very interesting.
I'd like to just reinforce, you know, the importance of that, and I'll even say it on behalf of Kratos. We need to innovate here as well, and the reason for that is, you know, I got into the satellite industry about a decade ago, so I'm actually kind of a newbie in this industry, and I will tell you, when I started, you know, it was mostly a wide beam satellite world, and you could get global coverage for a mobility network with a handful of beams. You know, HTS satellites now come out. You know, very prevalently used throughout the industry. Global coverage takes tens to hundreds of beams. Now you look forward to MEO constellations like mPOWER or some of the future LEO constellations. Now all of a sudden it's thousands of beams. So to further Karl's point, the need to automate and leverage tools like the broader communications industry is absolutely paramount. Because the complexity of these networks it's increasing dramatically, surely just based on scale.
Sure. Guido, do you have anything? I mean, do you have anything to add to this in terms of the day-to-day management of this interference problem?
Just to mention that, of course, here also is mainly manual failures because of poorly installed VSAT terminals or non-well-educated end users. So here, what we can do from our perspective is really to accompany our customers and to keep in close contact with them during the line-up processes, and to have a kind of checklist, right frequency, right polarization, right satellite, in order to avoid this interference from the beginning onwards. But when it comes really to an interference, which we are not aware of, then we have to rely on a close cooperation with the operators to figure it out, and then to get the processes done in order to shut down the carrier immediately and solve it. Yeah. But yeah, we cannot many things do on a automation systems here. So we, again, for us, it's the processes work together with SAS or Kratos and to solve this issue then.
Thank you. Let's stay with you for a moment, because I do want to, it's come up in our discussion several times, but I just want to drill a bit more into this issue of the future of automation and machine learning or artificial intelligence in managing these networks, and of course in big data analytics and actually optimizing them. Karl has spoken very passionately about that as a future requirement, and even today requirement. How does that look from your point of view, Guido, and what's sort of ahead in your own service provision as you're now actually merging two companies into one and covering a much broader marketplace?
Yes, what we already see today, again, that the customers are requiring more and more this kind of flexibility, what sooner or later cannot be done by human beings. So topic of artificial intelligence become more and more important. But I think we are still at the beginning. We are at an early stage, so there isn't not so many tools available on the service provider level. But sooner or later it will come. I mentioned some things earlier that, for example, you have a Maritime networks and the customer want to have his the maximum throughput almost where his boats are or his yachts are. So that means you have to move the beams or the data like the AXESS, like the satellite operators have to move their beams. We have to move the bandwidth. Maybe today it's in the Mediterranean and tomorrow it's in the Atlantic and then it will be in the Caribbean. So this has become very, very flexible here. The same is up and downgrade. Again, today I think that for sure the operators and also the hardware manufacturers are a bit ahead with creating the right tools and systems on the AI level. But sooner or later it will come to the service provider level as well.
It's interesting. There's a question from the audience which I think is relevant here, and that is, and maybe it's too soon to answer it, as you say, it's early days. But the question is, how, as we implement AI into the service management issue, how much is too much AI for this problem? You know, at what point, where do we maintain that balance between the human judgment in the network and the and letting the machine solve the problem for us? Do you have a view on that yet?
Yeah, Greg?
Yeah, no, I'm sorry, Guido, I wanted to keep going with you. Go ahead.
Okay, good. Again, when we look to the SD-WAN technology, I think this will be handled someday completely automated. So no human being has to be involved. If you have different kind of communication pipes at the site, MEO, LEO, GEO, plus Wi-Fi, plus other stuff, then you have your SD-WAN, and it will controlled by artificial intelligence, select the right path, the best path, the cheapest path, and will do everything. And also on other applications and issues, it will be easy to get an automated system in place. But again, if there are some urgent things to do a quick installation on your remote site because there's a war or Ebola crisis, you cannot send a robot today. You still have to be very flexible and send humans there. So I'm quite sure that there will always be a quote for human beings. So.
Well, that's a great relief to everybody in the industry. Guido, thank you. Karl, let me ask you the same question here about just automation. Yeah. You've already spoken about it and made yourself clear in terms of getting that balance right. Service provision in the hands of human beings, service provision in the hands of artificial intelligence. What's the right balance?
I don't think it's something we have to worry about anytime soon. Too much funny enough. I think we've got a long way to go before that's a problem.
Yeah, but, well,
I mean, the kind of systems, the kind of approach that we have at the moment is, we need to be able to, like, customers are actually are asking for portals that they can log into and see on a map, Google Maps, where their ship or plane is. They want to see the sort of bandwidth and top 5 KPIs for that vessel or terminal. They want to see all the vessels on a map. They want to see, the aggregated bandwidths, ESNOs, that kind of stuff. They want to see, in some cases, some customers want to see the carrier measurements from the gateway station, the downlink EIRP, this kind of stuff. And we actually provide that to some of our key aero customers today. And this is something, this is not even AI. This is just kind of, it's beginning on the path to AI. So this is basically basic analytics, and it's also, service situational awareness, where you compile a picture of the service landscape for customers, to showing them the state of, for example, the ground segment, maybe the weather conditions at the gateway site, or at the terminal site, even some additional things like predictive weather forecasting, to warning the customer that there is a heavy thunder cell approaching the gateway. There's likely to be a service interruption in the next, whatever, half an hour, 2 hours. This is something also customers are asking for. So the kind of low-level analytics to help the customer understand what's happening to a service. And by providing more of these functions to him directly through customer portals, it means that he's more informed, but also doesn't feel the need to contact an ops center to ask what's going on with my service or what happened half an hour ago. So it's actually pushing more of that data into the customer's hands, which means that their own operational staff, operation centers are geared up and ready for, if there's an approaching weather event, then they're ready to take some calls from their end users, and that they don't actually have to contact an SES operation center to clarify what the status is. So, these are the kind of really basic things on the analytics paths that we need to get right first. And that means all of the underlying data, the way we handle that huge amount of data from global infrastructure, global platforms and services, how is that data managed and organized inside our organization? From the spacecraft telemetry to the Monix CSM measurements that we extract and process, to platforms, to ground infrastructure, even to the CRM and asset systems, joining all these things together to build a picture of a particular service in a particular region at a particular time. This is something that is a huge challenge. We're already tackling it internally in SES. In fact, we have in the technology department, we have a digital transformation office, which is set up specifically to look into this area and also to drive enterprise architecture, to use things like global events processing and distribution to all of the various different consumers, automated reporting, to have a kind of a data lake infrastructure. So as a user or consumer of this data, whether I'm a guy producing reports or a commercial guy or an operations or engineering guy, I connect to a single source in the data lake and then pull out what I want, hopefully in a correlated and structured way. So our problem is nothing. It's the same as the telcos have or had in previous years. We're just, I think, as we scale up, we're kind of playing catch up in some areas. But this is really key to our survival in the industry, and the plan to be a kind of a global telecoms or service operator, it's absolutely a must to get this stuff right. So once we get the basics right, the underlying, the foundations right, then we can think about machine learning, artificial intelligence. But I think that's a way off. But we've got to get there, and we've got to start at the bottom in the NOCs. So to get rid of all the donkey work in NOCs, increase the use of self-service portals, even self-recovery systems. So on a small scale, there's no way there's going to be a sort of overnight transformation. It's kind of an incremental approach.
Well, it is a huge one. And Greg, just from you, you've already talked about this to some degree, but what's next on your to-do list in terms of achieving some of the understanding of the network and the ability of the network to respond that Karl and Guido have spoken of?
Both of them touched on the importance of data, right? AI and machine learning is only as good as the data sources that drive it. And the fact of the matter is, in most networks today, a lot of the data is there, but typically in a satellite network, it's historically been siloed. So you can grab very valuable data out of the element management system of a VSAT system. You can grab great data out of a carrier management system, whether that would be Monix from Kratos or a spectrum analyzer from someone else. You can grab great data out of SatGuard, like we talked about. There's teleport automation systems. There's even the switches and routers for the terrestrial networking handoff points. So all of the data is there. I think typically the challenge that you run into, it's similar to what Karl described, right? If it's all stored in different data sets that aren't necessarily compatible, your ability to bring all of that together into a data link and then feed AI is a great first step for us to attack. At Kratos, we do that through a new platform we launched earlier this year called Kratos Management Platform. And at the end of the day, that's really all it is. It pulls this valuable data from all of these historically siloed systems It allows you to have a common user experience, but I would tell you more importantly, it gives you that common data set so that then you can apply tools, third-party tools for AI and machine learning that allow you to then take advantage of those data sets to either quickly correlate problems or to provide up to the moment status information for customers through portals, or even pull in third-party data sets such as weather.
It's you, by the way, and thanks to both you and Karl for using my new favorite word in technology, data lake. I'm going to put on my swim trunks and jump into the data lake. We're getting toward the end of the time that's available to us, so we don't have much time for this. But I just want to quickly ask each of you, in terms of the future. We know what's coming at us, whether it's 5G, LEO, software configurable satellites, whatever it might be. What's on the horizon that you think is going to have the biggest impact on this whole issue of running a VSAT service in general, and our ability to optimize it for you? So, Karl, could you just give us give us 60 seconds on that?
I think the big challenges are, I guess, potentially thousands of LEO satellites operating in bands close to ours. There's the 5G impact, maybe not so much on VSAT because it's likely to impact C-band only, but yeah, I think it's the growth of it. Depends on how fast the LEO constellations grow, who's successful, how many satellites are up there. In 5 or 10 years' time from now. This is almost an unknown. Of course, these constellations are designed not to interfere with existing services, but we won't really know until these things are up there and in full operation. So this is a challenge.
Yeah, Guido, what are you foreseeing as having the biggest impact on your VSAT business?
Yeah, I'm always positive. So I think that even that both the 5G networks and also the LEO constellations and also the new MEO satellites will be a benefit for us. This will all enable us to provide more services and more bandwidth to our customers. On the LEO constellations, there's another view, another perspective. Of course, we are already working on several proposals for becoming a gateway partner on our worldwide existing teleports, because also these LEO satellites, they need a gateway to fill the traffic into the sky. But we today operate already several MEO services in Latin America and Africa. So I'm very, very sure that it will help also with additional MEOs and LEOs to provide more services and more bandwidth. Again, the bandwidth demand is there. I just have to mention all the download services, Netflix, movie, digitalization, so the applications will grow. We need definitely more bandwidth. It will come, but we will also sell it.
That's fantastic. Well, that's a very positive vision of the future. Greg, last word to you.
I think one of the primary things that we look at when talking about the future is how these networks move from historically hardware-based networks to software-defined networks. We've seen that movement largely in the terrestrial industry for the last decade. It's a huge part of 5G in the way if you look at 5G networks are built, and ultimately that gives us a lot of hints of what we need to focus on as an industry for satellite networks. Satellites are already software defined, which means they're reconfigurable on a regular basis. The networks we interconnect with in the terrestrial world are also software defined. It's really imperative upon us to be able to provide the connection between the two with a software defined gateway or a software defined teleport. In doing that, as these complex networks continue to grow, topics like interference can be handled much more effectively because the network becomes inherently more dynamic, and the data sets that we use to manage those networks allow us to be much better at predicting the problems before they even occur.
Well, thank you. I want to thank all three of you, Karl, Guido, and Greg, for a very interesting hour that I walked away from better educated than I was before. So again, I'm very grateful to you for that. And my thanks also to all who attended today and to Kratos Network for their support of our report and this webinar. And we look forward very much to welcoming you to our next webinars. For WTA, this is Robert Bell.